This is the second video for 1.14 pre-calc, so I'll label it B for you. And you might not be able to just look at this problem and determine that it has a y-axis symmetry. Or as you recall, or if you just watched the video, you probably recognize that even functions are symmetric with the y-axis. So what I'm showing you is how you can analytically figure that out. And you might actually clue into why we call them even functions. But I don't want to get into that right now. All you have to do is double check. What happens when you do f of negative x? Well, if you plug in negative x in for all these x's, you have this little fancy function. And then you're asked to simplify it. Well, what happens if you have 3 times negative x? You get negative 3x. But what about the absolute value? Is that's going to switch it back to a positive 3x. So it doesn't matter if x is positive or negative, that value is going to be the positive version of it. And then same thing with this. It doesn't matter if x is positive or negative. Once you square it, we always get the positive version of whatever x squared is. So this is what f of negative x is equal to. Let me just rewrite it. And the question is that exactly the same as what was written up here? And if that answer is yes, it's exactly the same, then this is an even function. Or maybe if it was a yes-no question, yes, f of x is even. What else does that mean? It means it has a y-axis reflective symmetry. And and we could look at a Desmos and actually see what that looks like. Same thing with g of x. So I'm just switching colors. All you have to do is see, well, what happens when you plug in negative x in for all those x's? Well, if you have 4 negatives, negative times a negative is positive, times another negative times a negative is another positive. What I'm saying is we're back to being the original problem. Negative x when you square it is positive x squared. They're equal values. So what we're saying is g of negative x and g of x are exactly the same thing. So I would just rewrite this. Yes, g of x is even. It has y-axis reflective symmetry. So let me just pull up Desmos, and maybe I'll show you f, and then move on. So just to show you what f looks like. I already forgot what it was. Plus x squared. And if you're looking at that, I think you can clearly see that this function is a reflection over the y-axis. You can look at x values if you want and see that the y values are the same when the x values are the opposite. So here's another problem where they ask you to plug this in. Now this is where you would have to be careful about memorizing, oh, well, all of my exponents are odd now, so it must be odd. This is why I don't like saying that. But if you use your graphing calculator, if you use Desmos, you might actually see something different. But the way to test it out is to plug in negative x's into the problem. And as you do that, remember if you have 3 negatives, maybe I should do some preliminary work of reminding you that negative x times negative x times negative x. Well, 2 negatives will make a positive, so you still have a negative there. So it's the same as being negative x cubed over negative x, and then change that to be plus 2x to the 5th. Now here's where you have to be smart about things, because we can simplify this as long as you divide the top and bottom by the same value. So I'm writing divide by negative 1. So that's actually equivalent to positive x cubed over positive x minus 2x to the fifth, which lo and behold is equal to the original problem. So even though we had a bunch of odd exponents, this is actually an even function. And you can visualize that by using a graphing calculator or Desmos. And you don't have to change the name of it, but I will. Just delete all this. Make it a division, x cubed over x minus 2x to the fifth. And what you're seeing here is a y-axis reflection, because whatever this value is at 2, negative 0.77-ish, the positive 0.77-ish going up to 2. I'm trying to think of anything else that I want to touch base on before moving on. So if you were asked to graph this, you would see this. So it is reflected over the y-axis. And I already forgot the other piece. Looks like there's asymptotes over here. I'm not going to draw a perfect graph, but they are reflected. Oops, that was a terrible. You'll use your imagination. If you want a better graph, go to Desmos or your graphing calculator to see exactly what it should look like. All right. So let's move forward to a few other examples. And this time, what you're doing for an odd function is seeing that they are the opposite. And again, you could probably see why we call them odd functions based off the exponents, but you do want to be careful as we go further. So all you need to do is plug in negative x. And the same rule we established earlier, that this is equal to negative 3x minus x cubed. So I usually ask students to do one more step. And that one more step is, imagine for a second that you're trying to compare that to negative f of x. Well, what does negative f of x actually mean? Is it's going back to this original problem and dividing everything by negative 1. Well, if you do that, then you get negative 3x minus x cubed. And what do you notice between f of negative x and negative f of x? Those are equal. You may get a slightly different explanation from a different teacher, but if this is true, then it is an odd function. And what does that mean? It is rotational symmetry. Rotational symmetry around the origin. And you can do the same thing with this other function. Let me switch colors for g of x. It's also going to be odd. All you have to do is see what's g of negative x. So that's replacing all the x's with the problem with a negative. So as we simplify this, whoops, that was supposed to be an absolute value. As we simplify this, you get negative 2x. This becomes plus x. And what does the absolute value do to that negative x? Well, it just goes back to being 2x. And what do you notice of all that? That's equal to the negative, if I were to distribute a negative in here. So g of negative x is equal to negative g of x. So I'll go ahead and just rewrite this straight down. So what does that mean for g of x? It's odd and has rotational symmetry about the origin. So these next couple problems is just asking, does it have even, odd, or is it neither? So you can feel free to work through this at your own pace. But as you look at this first one, yeah, again, feel free to do this on your own and then see if you get the same answer as me. Well, as you look at this, the negative, once you square it, gives you positive, so 3x squared, and then minus. So as you compare this to the original, well, it's definitely not the same, so it's not even. And if you were to distribute a negative in there, Well, that's not the same, so it's not odd. So it's not even, it's not odd, then it is neither. Now, it might have some sort of symmetry, but it's nothing special. So f of x is neither in this problem. Same thing with g of x. Your test is just doing g of negative x. So that's 2 times negative x, absolute value of negative x, plus negative x once you square it. So what we're looking at there is negative 2x, the absolute value makes it positive x, and then negative x once you square it, that's the same as being positive x squared. So definitely not the same of g of x, so it's not even. And if you distribute a negative in here, that's not the same, so it's not odd, so therefore it must be neither. Now hopefully that all made sense. So here's another example where students get in the habit of looking at that and saying, oh, odd exponents, oh, it must be something. So what you want to do is just double check what the math is. So that's plugging in negative x in for all those x's. So this is equal to negative 2x plus 3x cubed all over 2, and the absolute value of a negative is just the absolute value is the positive. So now what I'm looking at is the fact that you could factor out a negative 1 in the numerator. Whoops, I should have been minus. Minus 3x cubed. Because you only want to factor out one of them. So as you're looking at that, you see how what's in the parentheses there is equal to p of x. Probably shouldn't have said parentheses. Let me highlight a little bit better. This set of parentheses, that's p of x, and then you have a negative in front. So what I just showed you is that p of negative x is equal to negative p of x, which we learned that this must be an odd function. And again, I would go to Desmos to show you, but I think you're starting to get this. Plus I'm running low on time, and I think you're ready for the homework. So I'll leave it up to you to verify that this very last problem for p of x is odd. And yeah, go ahead and get busy.